Section 7.4 is about the difference between two squares. And it looks like the form of this. When you got something like u squared minus v squared, it will equal, in parentheses, u plus v times u minus v. So the u and the v are basically letting us know that we're taking the square root of the first term and putting it in the first part of each parenthesis, and the square root of that second term and putting it in the second half of each parenthesis. Notice that the first one is addition and the second one is subtraction. So they look identical except for the difference in the signs. One's plus and one's minus. So for the first example, 7.4a, notice they've got 4x squared minus 25. The square root of 4x squared is 2x, and the square root of 25 is 5. So this step is just showing us what the square roots are. Here's what they're placing it into the answer. So they're taking that square root of 4x squared and saying that it is 2x and 2x. The square root of 25 squared, or the square root of 25 is 5. So our answer, 2x plus 5 times 2x minus 5. Now they're showing you here you can check it by distributing, doing your FOIL, and noticing that you'll get the two numbers in the middle, the two terms that cancel out. That brings you right back where you started. Okay, so here is the answer. Now sometimes it looks a little different. It may not be as obvious that it's a difference of two squares, like our second example here, where they've got 9x squared minus 36y squared. Even though 9 is a perfect square and 36 is a perfect square, we really need to factor out a GCF first. So whenever possible, factor out a GCF first. Now with 4 and 25, there was no GCF, so we just started right in. But with 9 and 36, we can divide them both by 9. So if I divide or factor out 9, we're left with x squared minus 4y squared. So we're going to keep this 9 that we factored out, and we're going to do the square root of the first term, square root of the second term. The square root of x squared is x. Square root of 4y squared is 2y. So we're going to keep the 9 in the front, and we'll have x plus 2y times x minus 2y. All right, now we'll have a couple more examples. Here they're just showing you that they're checking it. Or they're showing you another way to do the same one. Example 7.4c looks a little more complicated, but it's going to be worked the same way. I still need to do the square root of 16, a to the 6th, b to the 4th. So the square root of 16 is 4. When we're doing the square root with an exponent, like a to the 6th power, we're really dividing it by 2. So the square root of an exponent is dividing by 2. So the square root of a to the 6th is a to the 3rd, and the square root of b to the 4th is b to the 2nd. Okay? So then when we write it out, we've got, because the square root of c squared is just c. So we've got 4 cubed b squared plus c and 4 cubed b squared minus c. The same can be done with fractions. We're still going to just be taking the square root of each fraction. So the square root of 1/4 x squared is 1/2 x. The square root of 1/9 is 1/3. So again, with the fractions, it's just, we know the square root of 1 is 1, and the square root of the denominator, in this case 4, square root is 2, and 9 square root is 3, okay? And then you write it out in the same format, 1/2 x plus 1/3 and 1/2 x minus 1/3. Now there are some that you can do a couple steps to. So x to the 4th minus 1, the square root of x to the 4th, we said divide it by 2, it's x squared, and the square root of 1 is 1. So when you write this one out, you'll have x squared plus 1 and x squared minus 1, which is fine. But then we notice that x squared minus 1 can be factored again, because x squared is a perfect square and 1 is also a perfect square. So we can factor this part again. So we still have the x squared plus 1. That's a of addition of two squares, which cannot be factored. So that stays the same. But this difference of two squares can still be factored into x plus 1 and x minus 1. So this is the full answer with all three factors, okay? So let's try a couple of these. So again, this is our format. Put this in your notes that we're using u squared minus v squared, and it equals u plus v times u minus v. And then we're going to do number 2. Number 2 is x squared minus 4. So the square root of x squared is x. The square root of 4 is 2. So x plus 2 and x minus 2. All right. And that's as far as it goes, because, check this, doing the subtraction and make sure that you don't still have, perfect squares, which we do not. So we're done. For number 10, notice 4 is a perfect square, but I need to take out a GCF first. And the GCF for these two terms is 4, which will leave me with x squared minus y squared. This is a difference of two squares. I'm going to keep the 4 in the front. And I'm going to factor this difference of two squares, x plus y times x minus y. And again, make sure the difference is not perfect squares, and we're finished there. Now, number 20 looks a little different, but it's still a difference, subtraction, of two perfect squares. The square root of a squared is a. The square root of b plus c squared is just b plus c, okay? So we're going to do a plus the b plus c, and then we're going to also have a minus b plus c. Now notice I had put parentheses around this b plus c. I didn't put it here because it was addition, but we've learned that if you're going to do subtraction, you need to put that parenthesis around to remind you to distribute the negative. So we've got the first parenthesis, a plus b plus c. Nothing you need to do there, but let's go ahead and distribute this negative. So it's a minus b minus c. And here's our answer. Okay. The very last one, notice it's got powers that are, higher than the square that we've been working with. That's kind of a hint that this may go further. So we'll do the first step, square root of each one. The square root of x to the 4th is x squared. The square root of y to the 16th, we're going to divide that by 2, which is 8. So here we go. We've got x squared plus y to the 8th, x squared minus y to the 8th, okay? And because this one is subtraction, can still be factored again because they're still perfect squares, we'll keep the first one the same, x squared plus y to the 8th, because the addition can't go any further. The square root of x squared is x. The square root of y to the 8th, again, you're dividing by 2, will be y to the 4th. So I've got x plus y to the 4th and x minus y to the 4th. Now I'm checking the subtraction. Now y to the 4th is a perfect square, but x is not. So because they both are not perfect squares, we can't go any further, and this is it.